Hello and welcome back to the CCENT journey with me, Ryan. In this next section, we're going to continue with the routing element of the ICND1 or CCENT, and we're going to look into configuring and understanding RIP, the Routing Information Protocol. This should probably be the last video in the routing section of the ICND1. For those who don't know, you can contact me here on YouTube, on LinkedIn or Twitter. Okay, so following on from our last video where we talked about the RIP protocol in general, we're now going to jump into the configuration side of it. Now in front of us we've got a packet tracer opened and we have 3 routers. And what we're going to do is configure the routers. We're going to look at the discontinuous networks, something I mentioned in the previous video, and then we'll get the configuration correct across all 3 routers and then do the verification. So first off, you can see that I've got 3 routers, all of which have got the IP addresses assigned and interfaces are in the upstate. So we have pings that are successful between the 2 routers, or between the 3 routers, sorry. But of course, because we don't have routing enabled, router 1 is unable to reach router 3. We've discussed so far in all the videos, the routers by default only know about their connected routes. So router 1 can ping router 2 because they both share this /24 segment. Router 2 can ping router 3 because of the same. But because router 3 is directly connected to this segment and router 1 is not being told about that network by router 2 because we have no routing protocol like RIP enabled, this means that full end-to-end reachability is currently not possible. So what I've done is I've put together the configuration of each router. We can see here on router 1, we would enter the process by doing router RIP. We would make it version 2. This will ensure that RIP is multicast, not broadcast, and supports classless networking instead of class full. We've got auto summary turned on, and we have 3 network statements. We have the 10.10.10.0 to match this here, which is actually a loopback on router 1, and the 192.168.2.0, which again is also a loopback on router 1 to generate some routes into the network. On router 2, we have router RIP, version 2, the no auto summary, and a single command. A single network statement that encompasses both /24s. This means that when we enable this on router 2, it will start sending the RIP process out both interfaces. And then I've got a blank to what config would I actually put on router 3 to enable end-to-end reachability. So looking at the screen at the moment, do you know what configuration you would put in here to actually ensure that router 3 is able to ping router 2's loopback? Router 1's loopbacks, and router 1's loopback is able to ping router 3's loopback. You may also notice when looking at this, there are maybe some errors with the configuration I've put together for 2 and 1, and can you spot those errors and what those errors may cause? So let's jump into the config and have a look at how we get on. So first up, we're going to configure router 1, and we can configure it by literally clicking on the icon and it brings up the CLI. And then from the CLI, we need to first of all do our verifications to ensure the interfaces are in the upstate and the correct IPs have been assigned. So looking at our network topology, we can see that we're using the 192.168.2/24 subnet. So the router's interface will have an IP address inside this /24. Since it's router 1, logically speaking, we've actually assigned it the 172.16.2.1. We also need to make sure the loopbacks have been correctly set up and they're also in the up state, which again means that it's up from layer 1 perspective, up from layer 2 perspective, and now we can advertise it into RIP. So let's go ahead and look at the configuration. So first up, show IP interface brief. We can see that gig00 has an IP address assigned to it correctly and is in the up state, and same is true with loopback 0 and loopback 1. So now let's jump into the RIP process and configure what we have in front of us. So we go into the config terminal, we do router followed by the protocol we want to configure. In this case, it's RIP, the Routing Information Protocol. We select our version. We have the option of version 1 and 2. Depending on the platform, it depends on which version is set by default. However, 99% of the time, it's going to be version 2 from now on. Once set, we're here actually going to pop in auto summary, and then we're going to type in the network statements to match the interfaces we want to enable the RIP process. So in this case, we want to type in the 10.10.10.0, and we also want to type in the 192.168.2.0, and now the link between router 1 and 2, 172.16.2.0. Now we can verify that by looking at the show running config, and ideally we would pipe that, but pipes don't work inside Packet Tracer. So we'd go down to the configuration, and just like we learned in the previous video, we can see that some of the commands has been pushed back to its classful presentation. So even though we typed in the 10.10.10.0, it's gone back to the 10/8, but we know from our previous discussions that doesn't mean that it's now enabled for the /8. We know because it's classless, it's going to look at the interfaces that start with 10 and enable the RIP process. We can also do the show IP protocols, and that will give us a bit more information about the RIP process that we have running on the system. This is one of the best verification commands when you think about routing protocols in general. We can see which interfaces we've enabled RIP on and which version each interface is running, because the version 1 and 2 is on a per interface basis. Because if we had an old device that we had to do some sort of backwards capability, we could turn that to version 1. We can see if there's any access list controls, ACLs, so that's something you'll learn about in the ICND2. What timers, so how often is RIP going to send updates? How long should it wait before it considers a route invalid? How many paths would it potentially load balance over? So if we learn the 10 dot network from 5 different locations, it will install 4 of them into the routing table. Which networks have we enabled RIP on for? And which gateway devices are we learning routes from? So at the moment, no one else is running RIP with us, so we don't know anyone else in the network. And of course, the distance. Remember, this is the administrative distance. For RIP, it's 120, and that's something very key you need to remember for the CCENT. So let's jump over to router 2 and configure that. So to configure RIP on router 2, we first of all need to click into the router to bring up the CLI, and then we need to go through the verification to check that the interfaces are in the up state. So again, we'll do that by doing the show IP interface brief. And we can see that we have gig 00 and 01. We know 00 is the link towards router 1, and 01 is a link towards router 3. Now we know that the interface is in the right state, we can go ahead and enable RIP. So again, config terminal, router RIP, version 2, no auto summary, and then we'd put in a network statement to capture, or to match against, I should say, the interfaces to which we want the RIP process to be enabled on. Now in this scenario, we have 2 interfaces, gig 00 and 01, that are part of the same match. So what I mean by that is by putting the one statement in, it matches against this and this interface. Well, let's say that we didn't want RIP to run on one of these interfaces. Well, that's something that you learn a little bit later in the ICND2 and when RIP gets more advanced in the CCNP. But for now, let's keep it simple. Let's get RIP enabled and see what this does to the process. So now we have 2 routers enabled. If we do the show IP route, I wonder if we were learning any routes from router 1. And we are. We're learning RIP, but notice something quite interesting here. Even though we put in the network statement of the 10.10.0, and even though it's running version 2, it's actually advertising to us a /8, which is the classful subnet of a 10 network. And the reason for that is not because the router is running in classful, but it's because we've done the auto summary. And remember, when we talked about auto summary in the last video, we said that it's a mechanism to which the router will try to summarize and then send updates on. So in this scenario, what we're going to do is we're going to leave it as auto summary, and we're going to see what the impact of that is. But we need to really put the no auto summary to ensure that the 10 network is not given to us as a /8, but rather as a /24. Because as you can see from router 2's table in the middle, currently it thinks any network that starts with 10 is reachable out this particular interface. But we know by looking at our topology that we have another network over here in the 10. So in the moment, router 2 thinks in order to reach the 10-10-20 network, it's to go out of gig 00. And this is the start of what we say is a discontinuous network because of that auto summary command. So let's continue with our configuration and come back to that. So some more verification commands we can be doing here is using the show IP protocols. And you'll notice that there's something a little bit different on this output as opposed to the one that we just seen on router 1. And that is towards the bottom. We talked about all of this, but when we looked at it on router 1, the gateway was completely empty. Well, now you can see it's not. Router 2 is learning of a possible gateway of the 172.16.2.1, which is this interface on router 1. So this says that the router 2 knows about the router 1 process and it's learning something from that process, and as such this 172.16.2.1 is a gateway for RIP. And if we were to go on router 2, if we were to go on router 1, router 2 would also be shown as a gateway with the 172.16.2.2, which is its local interface. So again, helpful command here because it shows us what networks are we advertising and who have we got as possible gateways to other RIP routers. So let's go ahead now and configure the last piece of the puzzle, which is router 3. So again, we're going to go into the router, check the verification by making sure that the interfaces are in the up state. And you may be thinking at this point, you don't need to do that. You can jump ahead and configure RIP, and rightly so you can. But the importance of doing this verification is to ensure you don't trip up later. If you come onto all three routers, configure RIP, and then wonder why it doesn't work, you could be looking at the RIP configuration, not realizing that actually it's the underlying interfaces or underlying IP process that isn't running as expected. So it's always good to start the verification before adding additional configuration. Otherwise you won't save much time adding the configuration if there's a fault. So we can see that the verification looks okay and we can configure the process. So the way we would really do this is to obviously go config t router RIP version 2, and then we would obviously type in the no auto summary and then the network statements. However, since I want to show discontiguous networks, I'm going to incorrectly set the auto summary, and then I'm going to put the 10 network, and I'm going to put the 172 network. And then what that's going to do is, just like we've seen on router 1, it's going to summarize the 10 network to a /8 and advertise it to router 2. But now we've got a really big problem because router 2 is going to have 2 /8s in its routing table. So let's jump over to router 2, and you'll notice straight away that we have the RIP process and it's learning what it thinks is 2 /8s for the 10 network, one out of one interface and the other out the other interface. So at the moment you would probably get intermittent reachability, because if you ping the 10.10.10.1 or the 10.10.23, you may or may not get the correct routing, because for example, it may decide to route the 10.10.23 out towards router 1 and router 1's network out towards router 3. And this is the problem with a discontiguous network, and this is why we need to make sure that the auto summary is turned off to prevent this, but we also need to make sure that the version 2 is on, otherwise it will kind of do the same thing. It will make the network class full, which we know is kind of very similar to this. We know that a /8 is a class full network. It's a class A network. So let's actually go to router 1 and router 3 and to make sure that the auto summary is turned off, because we don't want auto summary turned on. So no auto summary on router 1, and then across to router 2. And then if we go back to the middle router, give it a moment, and what you'll notice is something, again, relatively interesting. We've received the /24s, and you can see that it's just come in. One of them 2 seconds ago, the other one literally within less than a second. But the other routes are still there. And the reason the other routes are still there is because RIP has a timer mechanism that has to expire before the route is no longer valid. So we keep refreshing the table. You'll notice that this here is the timer of how long the route's been in the routing table, and the top route has been in there for a minute, and the bottom route has also been in there for almost a minute. And if I keep refreshing this, you'll notice that the 2 new /24s will continue to be refreshed, because we know every 30 seconds RIP sends out an update, and when that update is received, the routing table is refreshed and updated. But you'll also notice that the old routes continue to increment, and they will continue to increment until they're completely removed from the routing table. But of course, this delay of time of getting a route out of the routing table is, of course, in some cases not acceptable. You can't wait for minutes before the route is removed, and again, that's something that you'll learn more about in your studies through the ICND2 and CCNP. So a way to speed up the process, we're just simply going to clear IP route star, and that clears the routing table. And now when the next RIP updates come in from router 1 and router 3, we'll see that our routing table will now show the correct routes. So again, we're going to give it a moment because they're sent every 30 seconds. And there you go. We've got the 2 /24s, and we've got the also the other /24 from the 192 network. And then because the /24s are correctly subnetted, we know that this is no longer a discontiguous network, and therefore router 3 will have full end-to-end reachability with router 1. Okay, so that's all we've got time for in this lesson. Just to go over what we've done there, we configured RIP, we understood about the version 2 and the auto summary, and then it's really important that you get on Packet Tracer and you configure RIP. Now, a question that might be worth answering is when we had both the /8s and the /24s in the routing table for that period where the /8s were going to be taken out, do you think reachability would have worked? Well, absolutely. And the reason it would have worked is because the /24s are the more significant routes. Remember, the longest match always wins. So we have 24 bits in common and it's in our routing table, then remember the rules or the order of operations. Longest match over distance over metric. So when we had both /8s incorrectly because of the auto summary, and then we corrected it and had the /24s, straight away we would have had reachability while that /8 was removed. So in order to get by with the CCENT, you need to be able to make sure that you know how to enable the process using the router RIP. You need to understand the version 2 and why that's so significant. You need to understand the auto summary and why you may get discontinuous networks. You need to make sure you understand the network statement, that it actually matches interfaces and turns the RIP process on. And then you need to know the verification. So remember the show run, so you can look at the configuration itself. But remember, looking at the configuration doesn't show you the effects of the configuration. So to do that, we use things like show IP protocols. That's a really important command to remember because it shows you which interfaces you've turned the process on and which gateway devices are you learning RIP routes from. It also tells you which version you've enabled, if all summary is on, and it tells you, very importantly too, the timers of the RIP process. Now I hope this video has been informative, and I'd like to thank you for viewing, and if it has been, please do like and subscribe.